what we, yeah, it's Labor Day, but for for me, I have a full regular work day, which doesn't fit so well with the rest of my family. Uh, anyway, Monday is my busiest day of the week. Um, it ends up being uh, now I know many of you are behind in the homework, and I'll at this point I'll certainly be willing to take things late. It was difficult to get started with trying to work with um, virtual campus Moodle system, and some of the things actually are still kind of annoying. Um, they haven't added our class to the My Courses system, so you have a long fight to get to things. And then learning to work with the software in Excel, although the book's pretty good and we do have the videos available to you too, is always a bit of a fight. New software is a fight, and and that's something we can't get around. Uh, and I uh, yeah, uh, of course, I see most of you have muted things, and your um, computer microphones, as you know, will pick up what's you know background noise within your household situation, and so forth, or wherever you happen to be. I've been in some Zoom meetings where I'm looking at the side of the person's face, and the images are going past, and it's like, uh, let's see, those look like car windows. Is that his steering wheel in front of the guy? It's like, are you driving out during the meeting? Yeah, driving. I'm on my cell phone in the meeting. Yeah, that's um, not recommended. The classes are recorded, and we'll also I'll try to get some way that'll be modest to make up not attending and just watching the video. I haven't quite sorted that out yet. So let's uh, uh, let's get to the PowerPoint, and maybe we'll just go with a general share screen and look at what's up in the PowerPoint. Oh, chat. Okay. All right. Um, got a couple of private messages about late books. Yeah, that certainly can happen. I'll uh, I'll deal with that. Uh, and, and oh, you can see. Uh, I'm a little bit afraid to get rid of that one. Uh, that shouldn't be there, but uh, it is. And but this should be here, and we can pop it to full screen and go to first and more in the chat. I will we'll do the submitting of assignments in Virtual Campus. So maybe we can look at that today. We'll yeah, this is a bit annoying. From current slide and so we've got today straightforward statistics. Book descriptive statistics. Well, we have data, and one of the things we have with data sets, observations, studies, samples of populations, or data from populations themselves, is the statistics describe features of the data, the observation type, and we'll learn a few of those. It's September 7th. It's Labor Day. Okay, have somebody new popping in, and we can go forward on this and see. Can stop the share and see if I can grab up a few names. I think I saw Joseph, and want to go get my pen out. Unless you having a different login circumstance than you had before, we won't say anything about the tech use question here. We'll just try to see who's there. I think I saw Joseph, and we can stop the share and wait, stop share is what I wanted. So who do we see? I see did I see Joseph Blackcrow is there, and who else towards the front? Keckler and Garnier, and so we'll and Joel. Oh, Justice just popped in, so I'll see if I can click in a few of these names on a share screen. And it may be easier instead of me just trying to look, at least from my perspective. Do I have a pen? Grab up the pen. If you're there, if you could unmute yourself and just say here. So Joseph Blackcrow.
I'm here.
Okay. Right. Okay. Oh, I didn't plug in my um, pen tablet. Okay. Uh, uh, Kim Emilia Briggs. Okay. Felicia, I think I saw your name.
I'm here.
Okay. Ryan, I don't remember seeing yours. Okay. Uh, uh, Jermaine Garnier.
Here. Good evening.
Good evening. Terry Haskell. I don't remember seeing that one. All right. Saw Ellie Hornbeck.
Yep,
So,
here.
yep. And I saw Joelle. I'm guessing that's Joelle Janis.
I'm here.
Okay. And I saw Twani Rizzi.
Here.
So, okay. Brad Keckler. Thought I saw Brad.
I'm here.
Okay. And I was noticing I saw both Tiff King and Tamara King.
Yep, I'm
Here.
Okay. And Erica Kutswade. Don't remember seeing. Megan Martin. Christina Payne.
I'm here.
Okay. And I don't remember you logging in yet. Have you got a laptop?
Yes, I do.
Okay. Saw somebody log in with just the name Victoria. Which Victoria?
Hi, I added my last name. It's Victoria Phelps.
Victoria Phelps. Okay. Victoria Pena? No. Brittany and I talked for I don't know 20 minutes before class, something like that.
Yes, I'm here.
So she's here. Samantha Puckett.
Yes, I'm here.
Okay. And let's see. Sherry Turneyhart. Don't remember seeing you. Okay. Steven, I saw you, and I know sometimes you don't have a microphone or have difficulty using one. Shah, saw you. Yeah. And Justice, you're here. And Joni.
I'm here.
Okay. Joni's there. Let's
Yep.
see. We might want to pop over to virtual campus and look around a bit, because it's some of you are having some of the people are having some trouble there, and some of the folks haven't logged in yet.
I got mine figured out, Frank.
Okay.
This is Joni.
All right. Okay. I got a chat message. I don't know. I think you guys can't see this. All right. I've got you. Okay. Right. So let's. Well, I'm sharing the screen, right? So I can go here and I can escape this screen, or can't I? And stop the share. And then I can escape the PowerPoint. Okay. All right, I got the PowerPoint, and let's go. Let me see if I can pop over and get to virtual campus. And I can. Oh, oh, we should get out of that. Go here, and I can go to Zoom, and now. Okay. Yeah, the faces I see are a little surprising. Um, they bounce around differently, and some people have got their cameras on, uh, and and some don't. Um, we'll we'll have to check on that a bit. As this, if you remember from the last couple of weeks, some of you, I've got different background. I'm in a different room now. The other room is a little cooler. It's downstairs, and this is upstairs, and that makes it a little bit easier to contend with thermostats and all. Um, we'll. What did I want to do? Maybe we can bounce around a little bit on. Uh, um, what things look like on uh, uh, Moodle virtual campus. So just to get to that, so share. I'll go with a screen share, and chat window. Yeah, that's my plan. Have to use Moodle to submit things. It makes it a lot easier for me to work with. Trying to sort through emails gets to be real difficult. So here's a new tab, and just get to olc.edu, which I'm sure most of you have gotten to over the years, and services. It's called Virtual Campus, and that's what uh, Oglala Lakota College calls its learning management system. The software product they use is called Moodle. So pretty much the same thing for the course of this semester, and likely next semester. So we click on that. We go to Moodle, and I see I'm already logged in, but I can log out just to show the few people who haven't been there what it looks like. there are these site announcements and overall stuff, and then you click this and it's log in. It gives you a screen something like this, and the username, it's the same one for your email, and then your password, I believe, is the same as your
Same for both your email, your student ID, and then you go in and change your password.
okay. So there is a way to do this. Yeah, I don't. I'm not so sure what mine is there. It's hidden away.
It's about 40 minutes for that pizza.
And then I just hit it to log in, and it logs me in, and this thing on the side can either go away or stay. Now, my courses, most of the time, for most years, if you have a course that uses Moodle, my courses will sign up there. They currently don't for this class, and I am not sure why, but this was a sort of a fake class, practice using Moodle class that's sitting there fake for me, but that's the only class that's up for me. However, this time, kind of like to get it to look more like a student. So, what do I click? Log out, preferences, profile. On this site, I guess it looks the same if I'm student or not. Now they have all the courses in the school that are in Moodle laid out here. So there's a whole bunch of those. You can go through the list and find it. And I don't know, maybe there's a find in page feature too, and see if that works. I have kind of a weird name. And there are two in the page. So one is right there. And then where's the next? It doesn't show. So that doesn't work so well. I thought it would go down and find it for me. The better choice is to go all the way up to the top, and there's a collapse all, which gets you in humanities and social. I guess I should go back to where's that? Courses. There's the collapsed all set of courses, and you can probably see that list. And we only need to expand humanities, social sciences, and there's a long list there. Last time, last time I just clicked the 3, which is the third screen that'll show up. And my class was at the bottom. However,
In that course
there's a
search
problem
right there,
with it.
in that course search up there, I just typed in statistics and it came up with 2 of them and your name was one of them.
Okay, that's all you need to do?
Right up at the top of that, those classes you have there, there's a course search right there, up there.
Okay,
And I
Let
just
me-
typed in statistics and it pulled it right up. Right there.
course search,
And then type in your,
type the word statistics,
yep,
and go.
the
And
third one.
third one is here. And yeah, and then we can click on that. So that's the fastest way to get there. And there's the course information. And there isn't all that much on here, some general overview information and link to resources in the class from the textbook publisher and information about 2 weeks ago, the first day of classes, that week, and the others. And finally, this week's classes. And you can find out information about that. Now, I don't have the student view up yet, and I should switch the role to the student. Okay, now this looks a little more like what you see as opposed to what I see, which gives me hints on what I can edit. And I've got the link for the class. It'll be the same throughout. So you can go to the Zoom class meeting by clicking just that link. And notice too, for the last path, I've got recordings of the previous 2 classes. And I have the weekly PowerPoint, and I have the marked up PowerPoint too. So marked up is what happens at the end. And what do we have? We have sections, participants, and what can we see here? Anything? Have a calendar. Does that tell us anything? Okay. I got a chat message and have one student who will be in and out of service. And I've added nothing to the calendar, so that's not helpful. Grades for the class. I haven't had anything graded yet, but some assignments are available. And what happens if I click on one of these things? This is a quiz, and I can try the quiz at this point from chapter 1, and I guess I didn't change the date like I should have there. And there is a way generally to just hop back to other places, so you can bounce around a bit. We home dashboard private my courses can look um, there are the quizzes for the 2 weeks, and there are some problems for you to do. And there's a problem statement. There is some scans of the textbook. And what you do to add a submission, to add information, you click on this add submission, and it pops up a window like this, and you go into something like oh, what can I have? Oh, oh, okay. Uh, got a couple people who are driving now, and it's 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 rainy, and maybe they're doing their homework too. It's like hopefully that they're not actually the person driving the car while they're trying to watch the class. Um, it I do know that, for example, after you get out of town a bit, uh, things get kind of lonely on the reservation roads, for example. Although uh, it's still possible that you could drive off the edge or something. Another chat message. Okay. That tree at the moment. Oh, okay. All right. You have a drag and drop area, which is kind of nice. All you need to do is get some kind of go to a file explorer like this, where your file's located, any one of your files. And I've got a bunch of files for other classes. And what I need to do to upload it is just drag it over like that, and it'll upload. And then save changes, and you could submit your homework that way. More chat. Okay. Uh, uh, okay. Uh, all right. So that's a way to get to the homework. And as you can see, I'm not a very good student for the class because I haven't submitted my homework yet. But the game is to put stuff up into uh, Moodle Virtual Campus, and thereby making it easier for me to find all the files I need and to look at them. And am I still in Moodle? Yeah. And can I change my view? Return to normal role and make me look like a instructor, and then I can then go here and I can log out. That's it's enough of that. Minimize this, and we can work from the current slide. It's where we are. I looked at some of the overview, and it's in Genzabar. We'll use that for attendance. It's keyed to everything. We have across the campus, and I'm supposed to put my attendance in. I got and people do check on it. Late last week, I got 2 notifications. You didn't put the attendance in for the first week for these 2 students. It's like, yeah, I know that, but they weren't. There really isn't an appropriate statement for attendance for them because they weren't registered for the class yet. And they didn't say register. So people do look at it. I guess just a point of view. The how to get to new assignments. Just below that are the PowerPoint slides. So if you like PowerPoint slides and like them to study all clean, they're up there. Or like them dirty and marked up, they're up there. Now, the one comforting thought is all this technology, handling it, and trying to deal with people not actually being there, and not being able to respond real cleanly. We have chat window, and we have you can talk with your microphone to talk to me. I try to keep abreast of the chat window. There are some competitors to Zoom that I think do a little better with the chat window. We used to have it at the School of Mines. We're kind of done with that though, and we use Zoom there. People have done classes over the radio, and successfully. So Zoom's a lot better than just listening on the radio and mailing stuff. Of course, the mail might be better then than it is now, at least some places. Yeah, I don't know around Rapid if we've had any breakdown in the mail system, but when you try to send things across the country, they may not be moving quite as quickly as other times. So straightforward statistics, Chechen Bowen. What do we have? Constructing frequency. Ooh, that popped me. Okay, when I drag this, it popped. I don't know. So what do we know? We do know a bit about frequency tables. We do know how to construct graphs. Consider the impact of frequency when using tables for summation of x or summation of x squared. So how can we handle knowing frequency and summation of x and summation of x squared is something we have to think about in some manners. And what we're going to do new this time are measures of central tendency and measures of variability. If we start thinking about maybe a histogram of our data, of some things, a plot that describes how frequently we're looking at, or the plots that look like distributions, we might want to think of a way of what is the center of that distribution. And there are a couple of ways to think about what it should be. I think I had somebody drop out. And we've got measures of variability. And somewhat we can think about distributions or histograms and how spread out they are. And there are a few different ways to think about that. Measures of central tendency. A single number to describe the center of a distribution. Where is the center? Usually a typical or representative value for all values. When I teach at the School of Mines, the upper level industrial engineering classes, many of the students had gone through high school and did well, and they're going through college now, so they're in their third or fourth year of school. And so if you ask their age, what would be a typical age, it might be like 22 years old or something like that. And that would be the number there. If you're looking for typical ages of the OLC students, many of them have decided to go to school a little later in life, and they'd be a bit older. But there are different ways to do that, and some of these you might have seen already: the mean, median, and mode. And we'll describe these in detail. One you probably already know. Mean is sort of the way to describe an average when you took a statistics class. So pretty much to show you can handle courses in college. Although there are statistics classes. The first one is the mode. And that's defined as the value or category with the highest frequency in a distribution. So that's simple. It's applied to all four scales of measurements. A distribution may have one mode or no modes. Okay, have more than one modes. Start thinking about this. We look at the mode as the top of the hump that we had when we were drawing there But what if we have 2 humps in our distribution, or 3? That's entirely possible. And it's also possible, looking it over, that we might have like a completely flat distribution, a uniform, has no mode. So those are there. Distributions with 2 modes are called bimodal. Bi meaning Latin prefix meaning 2. The train tracks in Italy are called binary, like you would say binary, except with an I. It means 2, and you know, a bicycle is a 2-wheel device. Okay. I've taken the attendance already, so if the person who's newly arrived hasn't been there, you can mention my name and we can go back to that and mark you in. Okay. You can just say it into your microphone and or put it in the chat window. Okay. Chat window. I'm here. Okay. There are 2 people named Victoria in the class. I guess you're the one who I hadn't checked in yet. So let's go back a few slides. Victoria Pena, I'm guessing is the, okay.
Yep. A lot of people pronounce my last name because it usually is supposed to have the tittle day over the end.
Okay. Is that where we were? Talked about the mode. We can talk about the median. Well, I'd use a different definition, but this one works. It's a value exactly in the middle of the distribution when all the values are sorted highest to lowest. Okay, so we take all the values. Oh, my watch just told me in the last 50 minutes I haven't taken a step. And I think Brittany could attest to that. At least I've either been talking or there. So right in the middle of the distribution, take the data, sort of highest and lowest, what's in the middle. You realize if we have an odd number of an even number of values, well, the middle of the distribution will be a gap, not just one number. And we'll have to know how to do that. Requires that the data are ordinal or higher in scales of measurement. So ordinal or the vector type data that we have. If n is a not odd number, there's only one midpoint, so we find that middle number, whatever that happens to be. We find the location, and that's it. We find the location of the meeting in an odd number. Calculate L is equal to n over 2 and round up to the next integer. So n over 2 plus 1/2 also works exactly, but rounding up. If n is an even number, the median lies equal between the average of the two midpoints. Okay, so L is equal to n over 2 and previous L plus 1. The locations of the two midpoint. Oh. Imagine I had a snipping tool in PowerPoint. I don't. I actually have to use a snip. Oh, that's where I am. This statement should have been here. Okay, and I was dragging my pen someplace I didn't know where it was supposed to be. So now I get to drag the eraser. I think I've got it. Okay. Frequency table of daily network interruptions on a university campus. We've seen this before. I believe last week we talked about this. At least I seem to remember that. A week ago seems like a long time at the moment. The x value and the frequency, relative frequency, is 1. So identify the middle two positions. N over 2, there are 30. So the 15th position and the 16th. The 15th and 16th position, and how would we find the 16th position? We might add another column and think of cum frequency. Cumulatively, we've got 9 here, and 9 plus 10 is 19, and we can go down the whole way if we want and get to 24. Here's the cumulative, and so the 16th position the 16th position will be in this set. The 15th and 16th positions will be in this set where our cumulative values are between 10 and 10 and 19 here at this level. So 1. So this time the values are both 1, and the average of the two median values then is, of course, 1. So that's the median from that data set. So cumulative relative frequency, defined as the accumulation of relative frequency, particular value applies only to ordinals, interval, or ratio variables. Median can be defined as the first value with a cumulative relative frequency more than 0.50. So that's another way to do it, and we'll probably see a table of that. The relative frequencies. This 9 divided by 30 is 0.30. 10 divided by 30 is 0.33. And so forth gives us our relative frequency tables. Our cumulative relative frequency, the first one matches up with 0.3, like that. The second one is 0.30 plus 0.333 to 0.36, and so forth. We can work our way downward, and then have the relative frequency table. That's one way to reason through. Instead of doing a cumulative frequency column like we did previously, the relative frequency, the rule may be easier for you to follow. As soon as it gets over 0.50, it corresponds to the value where the median is. So that becomes an alternative way which some people may find easier than going through listing them all. At times, though, we could actually go through and list all the values from this, right? You list 9 zeros and follow it with 10 ones, and then you would count up to 15 and 16, and then do your calculation and get the answer. That's another way of doing it with a listing. This is a bit easier, although we discussed forming these entire tables here. And if you're working in something like Excel and just need to drag things down to get them, it of course is pretty easy to do and do it. But if you were doing with a hand calculation, you would only need to calculate. You could calculate just these 4 values to get your answer. The mean. You already know how to do this. Okay. It's an average. And there's a command in Excel for this. It's called average. We have sample mean, which is, we call it X bar. So we might just want to put down what we call the stuff. What do we say? What do I say when I write this equation? I say x bar equals sigma x over n. So that's what I'd say. And then, so this symbol is x bar. And this symbol here is sigma. This symbol here is mu. Okay. And pronounced like mu. Okay. So if you want to talk about this, and sometimes some people will say, instead of the sigma there for that letter that looks kind of like an E, they'll say summation. And I had one guy, you remember, who would say sum up every time he saw it. The common element for both the population and the sample mean is the summation of x. Variables need to be either interval or ratio, or not ration, ratio. Need to correct that. There is a way to correct that. I have a white pen. Oh, I lost my pen. Anyway, go back to a red pen. And we'll just cross that out, ratio, not ration. So those three forms. Some textbooks do this in one chapter, and then next subjects in the next. So if we have a relative frequency table, quiz scores from 0 to 5 on a quiz, and we want to figure out the average score. x bar equals sigma x over n. From this table, we realize that we have multiple x's with this frequency, so we have to put sigma fx, like the television network, right? Which has all the fancy computer graphics and things. Okay. This is one of those things where you really do miss actually having a live class. You probably have a few people smile or chuckle when you see fx. So summation of fx, adjust the formula. In this case, we are using a sample. So when you do have a frequency table, the mean for the frequency table is, we mean summation of all the x's, but it's convenient to use summation of fx, and we get 188, and we divide that by 50, so our mean is 3.76. Daily high temperatures of Cleveland, Ohio in January, with x midpoint and fx midpoint. So okay, we have a range and we take the midpoint of those high temperatures. Didn't say which year. For 30, we had a minus. We had a. Not every year do we get negative temperatures in Cleveland. Okay, I lived in Cleveland for 24 years. All right. Many of those years I didn't understand what. Well, a suburb of Cleveland, but usually looked at the Cleveland weather. Granted, most of those years I didn't have the concept of number. So we have midpoints of those intervals, minus 9.5. Might have actually been like a -6 that one time. And then between -4 and 5 degrees, had 3 days of those, and 6 with low temperatures. And 7 with low temperatures between 6 and 15 Fahrenheit, and so on. And 7 days in the lows of between 36 and 45. And one thing about Cleveland over the winter is it can be really slushy, and you can see that with these temperatures, with lows in the 36 to 45 range, or lows in the 5 to 26 range. You're realizing the high temperatures are often a bit more than that. Although, if you notice today, we haven't had that great of temperature shifts that we've had, for example, on Saturday, because it's often very cloudy there and overcast, and the temperatures tend to stay pretty even throughout the day and night, as opposed to here, where we get broader, more very commonly have broad temperature shifts. And I was thinking back about Saturday, about how I was up in the hills on Saturday, and it was both hot and amazingly dry looking. Just a lot of brown grass places. And so here's a calculation for the mean of the population, the mean low temperature in Cleveland of that particular January. Oh, those are daily high temperatures. I'm sorry. Whew. And it's colder than I thought. We can do weighted average too. Um, uh, don't often use this in this book. Uh, not every value is treated equally as with a GPA. Okay. Each course grade is weighted by the number of credit hours. So that's one way to think about how a GPA is calculated. It is a weighted average with the weights being the number of credit hours. GPA, grade point average. I'm just thinking almost in high school people dealt with GPAs, and most of you had attended a regular high school, I think. And we do discuss GPAs in counseling sessions, of course, at a college level. And for most of you, this isn't your first college class. And so you're familiar with that and how it's calculated. Let's see. We've got Chris's courses and credits and credit hours with a weight, a WX column. So credit hours are W. And we have 16 credit hours, which might be a reasonable load in a semester. And so person with 2 psych courses in behavioral science statistics, you might think that's a psych major, and we can see their grades, which actually look pretty good. Okay, worst grade was in psychology of women, and might have been a guy, although the name is Chris, because he really doesn't understand women as well as anything else. So we could joke about that. Okay. So WX is the weight times the value, and then we sum WX, and we have the summation of WX. So let's go to the pointer. This is the summation of WX, and this is the summation of W here. So when we calculate that, this is 50 in the numerator, and this is 16 in the denominator. And from there to there, there to there, and then when we do the calculation, it's 50 over 16, or 3.1. So Pretty good. Pretty good semester for Chris. Nothing terribly noteworthy, but certainly no problems with the grades. Now we talk about outliers. Those are the extreme values of the distributions. And the so these are numbers that are usually things that don't really belong. I guess one way of putting this, you go into a first grade classroom and look at the height of the people in the room, and the tallest person in a first grade classroom might be as tall as 5'3", for example. Realize that might be the instructor, the teacher, and then everybody else. I don't know how might be closer to 3'3" or so. I don't really remember heights of first graders. So the teacher is an outlier in the heights of the people in the classroom. It has a heavy influence on the mean, but not on the mode or the median. So you can maybe the annual incomes of people residing in your block, and somebody hits the lotto one year, and you count them, and then it blows up the average, right? If somebody hit the lottery and made $30 million one year, and if there are only 30 working people on that block, the average income's over $1 million, but it was just one guy hitting the lotto. And outliers may have a heavy influence on some statistical procedures. So outliers blow up some statistics, and what we often do is find a reason for declaring something an outlier and toss it out, but we have to make notes about that. Somebody hit the lottery big time. Now it changes all kinds of things. Now, this is nice when we have a normal distribution or anything symmetric with one mode. In general, the mean, median, and mode have the same value and are located at the center of the distribution. Mean, median, or mode. Now, when we're dealing with the normal distribution, for example, we might use the word mean when we actually might mean median. We might say the mean, it has 50% of the observations below it or above it. Well, that's true in this case for the normal distribution, but what we were saying there is a property of the median, but the mean, median, and mode line up all the same. There are other distributions that are symmetric. If it's symmetric and has one mode, that's true also. So we have some observations about mean, median, and mode here. Now, if we have right skewed or positively skewed, we get disordering with one mode, median, mean. So the mode is most affected by what happens in the tails, the median somewhat less, so the mode tends to be higher backed. So this is what happens in the mean is pulled over, the one way and towards the low probabilities, and the median, the mode then is often pulled the other way. So mode, median, mean when we have a right skewed or positively skewed distribution. And this is like the lifetime of parts or machinery or animals or people. And I'm thinking about my dog that's here in the room, was 15 years old, and the breed is only supposed to have a lifetime range of 10 to 12 years. So she's out there. Now, when we have a left skewed or negatively skewed distribution, we have the other sort of thing. So you might think the mean goes towards the longer tail. The mode is usually on the other side of it, other side of the median each time. So this is what happens with the negatively skewed distribution. And these might be the grades on a relatively easy assignment, would look that way. I remember giving one exam where the grades ran really high, and there were a few people who had low grades, and the guy who had the lowest grade complained that I didn't teach very well because he's a really smart guy, and the person, and he had the notes of the guy who had the second lowest grade on the exam. Yeah, I told him to go complain to my boss about that. Measures of variability. These get a little harder than the measures of central tendency. They're describe how a variable is spread out or scattered. Now that gets to be a little bit of a problem when we consider a distribution like this. Yeah. Okay. I don't know if the private chat. So, how is that spread? Well, you could look at the extremes, but still with that tail, if the tail was a little spikier, you might want to have a lower variability. If the peak was a little spikier, you might want to have a lower variability. If it was flatter, higher variability. And just how we do that is a bit of a question. And some of the distribution types actually have infinite tails. So how things are scattered, common measures of variability are the range, the largest minus the smallest value, pretty easy calculation, the variance and standard deviation, which end up being kind of complicated and for many of you, it might be the most complicated formula you've worked with. Now, all three require data to be interval or ratio scale measurements. The range, the difference between the maximum value and the minimal value. Highly sensitive to outliers, it only uses the two most extreme values. So range, maximal value minus minimal value. That's all the calculation you need, one subtraction. So there are min and max functions in Excel, so you can take a min over a range, and you can take a min over what Excel calls a range is different than what statistics calls a range. A range is a grouping of cells together that they're described within that grouping, and then you have actually a max and min function in Excel that work for that, but it doesn't actually have a range function like this. At least I had to find it. So the variance and standard deviation for a population. Okay, the deviation from the mean is x minus mu for a population. So this is actually the mean. This is the individual observation. So a deviation from the mean is x minus mu. The sum of all the deviations from the mean will always be 0. Ooh. Kind of strange, right? What happens is you realize this is the sum. We have the sum of all the x's divided by n. If we sum them all up, we'll have the summation of x's. And if we sum all of these up the same number of times, we'll have n times the summation of x divided by x, cancel the n's, and we get summation of x divided by summation of x, and it all goes to 0. So that's cute. And I just talked some algebra that you probably would have found confusing, but yeah, that wasn't probably the best choice. It works out that way. Might be the better way of doing it. Ages of family members and deviation from the mean. So household with likely 2 parents and and 3 children, and ages of the children are 17, 22, 26, 48, and 57, which doesn't sound too unusual. A bit of a large age gap between the 2 largest family members in the household, but otherwise doesn't seem to be anything too unusual. It's in families we might know. So these are our summation and the summation of x minus mu, and we can calculate the mu values equal to 0. So the mu there is 34, the average age of the people living in the household, although there are no people in the 30s there, which is of course common in households that you might have a large gap between children and parents in age. That there's just physical need for that, and societal things too. Because the sum of the deviations is always 0, it's not practically useful. One thing that's very common is to use the sum of the squared deviations, and sum of squared deviations in this book and a few others we just simply call SS. And so we take x minus mu, square it, and that's our sum of squares. The mean of the sum of squares is also known as the standard deviation for a population. And it is, we say here, sigma squared. So this is also a sigma. So this is capital sigma, this is lowercase sigma. So Greek letters, not often what people use real often. The variance and standard deviation for a population. 1 squared deviations from the mean are no longer on the same scale. Ooh, that gets a little odd. So if we took dollars and squared them, we would have dollars squared. And, you know, we don't talk about squared dollars because they might be fake, right? The square root of the variance is taken to bring it back down to the original scale. So instead of dollars squared, we have units of dollars. That's easy to understand and useful. So the square root of the variance is known as the standard deviation, and we say sigma. The square root of variance is equal to the square root of SS over n. The standard deviation is the most common measure of variability in statistics. Yeah, we could say that. As stated in previous chapters, population parameters are often impossible to obtain, so samples must be used. We have this technical term called unbiased. And we don't really define it here. What it means is if we continue to sample under the, okay. Unbiased means on the average, our statistic goes the right place if we continue sampling infinitely. Works, now that's, if we had a very large sample and sent it to infinity, our sample, as it got there, it would go, the average of our observation of that statistic would go to the right value that we believed it to be of the parameters. So it means something like that, which is kind of vague here, but unbiased. It's a nice property for a statistic, and the sample variance then is an unbiased estimate of the population variance, but it looks a little different. Up to this point, including the sum of squares, the calculation for the population and sample variance are the same. So you use the same sample SS. For the sample and the population, you do the same calculation for SS. Defined as the number of values in the calculation that can be free to vary in the sample. The degrees of freedom for the sample variation are degrees of freedom equals n minus 2. Try to introduce the idea of degrees of freedom here. At this point, it might be a little more trouble than it's worth. We calculate the sample variance, and X bar is used to calculate the sample variance. X bar is used to estimate mu. Accordingly, 1 degree of freedom is lost. So here's a little bit about that. So here's what S squared is. It also means variance of the sample. And we go through the calculation, and they use DF and SS and so forth. So we now have, instead of sigma squared and sigma, we have S squared and S. And for the calculations of degrees of freedom, calculations of when we have samples. Rather, now we also have to do this with frequencies. When working with frequency tables, we, instead of using our usual SS formula, we put an F B right after the sigma and include it with every term. So it includes the impact to the frequency. Right here, we might need to, is this number of pets in household. Now we don't know if this is a sample or an entire population. 40 could be either. And we take the summation of X bar, summation of X bar squared, multiply it times F, and then we can compute the total afterwards, and the total frequency or counts. And finally, what we don't do is actually do the final calculation. Maybe that's on the next page. Maybe that was the previous page. Okay. We get SS, we get degrees of freedom. N is 40, and we get 1.1. And then standard deviation, the square root of 1.1 is 1.0. Well, not quite. I might want to add a few more decimal places to that. It's if you square 1.0, you won't get 1.1. You need something, might want another decimal place just for that purpose. Maybe too few. Interpreting the central interpretation of central tendency and measures of variance. Okay. What we do see here is we have homework grades of students, and we have 3 male students, and we have um, uh, okay. Well, no, we have what 10 male students, and what is this for female? 12, 16, 19, 19 women, which you might find in like a psych class, a course more dominated with women and men. So if we were to go and look at the measures of central tendency just by symmetry, they're both symmetric, right? So we have 4 here, 2 on each side. So it's symmetric and has one mode. And when we have symmetric in one mode, the mean, median, and mode all have the same value. So the mode is 5. Similarly, we have symmetry here, but 4 the 1 step away, and 3 the 2 steps away, and 5 there. So the median, mode, and mean are all the same 5. So for both groups, they all work out to be the same. And we can tell that because they're symmetric and have one mode. We can work our way through and calculate the sample variance and sample standard deviation and the range. So we have a range about 8 for the male students' grades, and standard deviation of about 3, and a variance of 9.1. So that works out to be standard deviation of 3, range of 8. It's what we might use for comparison. We can do the same calculation, and we have a range of 4 and a standard deviation of 1.3 for the female students' grades. So the female student grades are more consistent than the male students in the class for homework scores. I've never looked at this kind of data for my students, so I don't know if this tendency is true or not generally, but it does appear that the female students are more consistent in their grades than the male students. So we now have different descriptive statistics comparing men and the women, males and female students. Might want to say men and women, but it could be like a high school situation, and you might want to say boys and girls. Always been a little uncomfortable thing. I just remember in high school there was a announcement one time: any boys and girls wanting to join the Marines, come here. It's like I thought they weren't looking for boys and girls. uh, as we can see, the measures of central tendency are exactly the same for both, and the male students have much wider variability. Males tend to have more extreme scores on both ends. Females tend to have scores near the middle of the distribution. This example shows the measures of variability reflect the magnitude of the spread of individual values in the distribution. So And we've got a boatload of formulas that we've talked through here. Probably the most formulas you've had in one lesson ever. Yeah, yeah, it's quite a lot. Well, it's a 3-day, it's a 3 credit hour kind of session, and I'm looking at my watch trying to figure out how much time I have here. And mean, we say mu is equal to the summation of x over n, and mean for the sample, x bar, is equal to summation of x over n. And these are averages, and there's an average command in Excel, and average is something you've probably done in elementary school. The mean modified in frequency tables. Mean for modified frequency tables. Well, where the x's were, we put in an fx. Okay, and works for both mean and standard deviation. The sum of the deviations are 0 for all means and all samples. If you know a little bit of algebra of summations, it falls out real quick. I talked through that just off the top of my head today. It probably isn't a good thing just to talk through algebra, and considering writing it out isn't something I'd like to do in this class. Not that it wouldn't be this appropriate, but little algebraic proof just isn't always real welcome among students in a class like this. SS original, this is what we mean by SS. If we have individual observations, we say original here. You might want to think about given individual observations. Might be better than original. Maybe I'll do that. By original, we mean given individual observations. And we have our given individual observations, and then frequency tables. And we now, using the SS notation, we don't have to write what we don't have to write other forms here because we use SS and then we use individual observations. So most textbooks won't put the formulas in this. They'll combine the SS terms in the formulas here for variance and standard deviation. And this is, we say sigma squared, and this we say sigma, and this is S squared, and this is S. Oh, this is a little simpler. Box plot and 5 number symmetry. Making these, used to always like to put these on like all my tests because they were easy. Here, put this on the final exam, see if you can get it right. So the first incorporates some central tendency and some various measures. The 5 important quantitative attributes are the minimum and maximum. Yeah, we know how to get those. The median and the first and third quartiles. The quartiles are quartiles Q1, Q2, and Q3. Quartiles divide the data evenly into 4 groups. The difference between Q1 and Q3 is the interquartile range, but we didn't talk about computing quartiles yet. And then we can draw these values this way. Quartile 1, quartile 2, this is the median, this is the max. And we put a box around this and whiskers here. These are often called box and whisker plots. We don't often have symmetry for these. In other words, they look different. And gee, that's the end of the slides they gave. I can stop the share and maybe, yeah, if I would have had a different last few days, might have jumped off a little bit different on what box plots are used for. Whoa. I'm just looking through the book here to they don't have a they only have a couple of box plot problems set up there. Let's actually just go and do a web search on box plots, and we might see a little bit more useful on those. Likely can find that. And I should go back to Zoom and share screen. And what have I got? My web I'll just share the screen. And I can pop up a browser and Google and Boxplot. And we can then just see images of box plots. We can use them to in images. There's a description of how they work. You can see multiple box plots. They don't look at all symmetric. There's some different rules about what you do with outliers, so they're not all the same. And so a whole lot of pictures there. Sometimes they look real flat like this. Sometimes they look stretched out like this. So there is a whole good value of images of box plots, and there's even a Wikipedia page for a box plot, so it's pretty common and has some more details about so a history of it, elements of it, more than you'd like to know, or more than I'd like you to know, and a definition here for the 25th percentile, the median of the lower half of a data set, and the third quartile, the median of the upper half of a data set. So there were different strict definitions of doing it, and different searches. For example, when we looked at box plots, the Khan Academy has a description of box plots in it. And even when we did our search for box plot, we got, for example, box plot in Excel. So there are some videos on how to do it in various types of Excel, how to create a box plot. So those are available and around. Supposed to have about a half hour left of what we should do. So stop the share. Might just overview with what we're doing here. Will I guess I look at the people who still in class, and I believe I've marked you all here. and we'll um, we'll keep that. I guess I could look over my slides again and talk through them and maybe mention some difficult points, unless somebody wants to interrupt with something. Okay, screen share, PowerPoint, share, uh, end of slides, click to exit. Do you want to save the annotations? Keep. Okay, screen share and shop. Okay, because the window itself closed, I can do the screen share of the screen itself. And I've got PowerPoint, and I finished with that. Um, talk through what we've done today. Maybe change the color of a pen to see if I can highlight some things. That's not the pen color. Uh, maybe a green for commenting on these slides. What do we have here? Did take attendance, and Terry Haskell is here, and I didn't have her marked, so I remember seeing the face. We can see that. Don't remember seeing Megan Martin or Erica, and don't remember seeing Sherry, but everyone else was here. We did talk through virtual campus again, and saying that's where things are put together, and we'll point to attendance assignments and overview. Showed how to get to new assignments, showed how to get to PowerPoint slides. And one point I make, although the Zoom doesn't work quite as well as a live session, we can, and maybe for this, I can show a video panel. And can I get, what does that do for me? Let's see who's there. Right. Let's see. Go back here. And yeah. Chapter 3, we do know how to work with frequency tables and measures of central tendency and variability. It's what we look at this time. So central tendency and variability, how we measure the center, and we looked at mean, median, and mode. We look measures of variability. We included some things. We had range, variance, standard deviation, and those different between populations and samples. We also snuck in at the end an interquartile range, which is also a measure of variability. Definitions of central tendency, it's a single number that gives us the typical ones. So mean, median, and mode calculations. Mode's real easy. just the highest one. And just grab it up real quick. And median, a little bit more difficult. The center number, if they're all listed as odd values. If it's an even number, it's the average between the two center values. So a little bit more difficult calculation. That gets a little trickier when we have frequencies, and you can get a frequency, and one way to do that is with a cumulative frequency to just get where those where that mid value or those middle values are, and we talk to that with the cumulative frequency. You can also get through it with a relative frequency, and you don't. It's a little simpler because a little simpler reasoning, a little bit more involved calculations with the relative frequency. And we just have to notice where we're going down that cumulative relative frequency where things pop over 0.5. So this one pops over 0.5 for this calculation at 1. And this is the number of network outages in a month at a university campus. So going through those, just wanted to make a point in the mean. We have a little bit of language. We say X bar, equals sigma X over N, and we say sigma for this E E-like thing. So students sometimes fail to remember these terms. Okay. And so that's a note. Population mean is mu. Yeah, it's a Greek letter, and usually write it mu, mu, and it's pronounced like mu, muw. And this mean only can use for interval or ratio measurement scales. Calculating the mean with the frequency table, you just replace the summation of x with the summation of fx. So this is sort of the cute part here. Noticing this goes to this. We can, when we have ranges, we can take the midpoint. When we have ranges in our data values, when we're doing like a histogram type of data, we can get the numbers that way. Here, the population mean is here the mean for the population is 22.8, which is the average daily high temperature in Cleveland in January. So similar thing with midpoints when we have a continuous scale. Weighted averages, that's how like a grade point is calculated. So we don't do that much with weighted averages in following chapters. And they work through a grade point example here. Grade point average. Outliers, these are the extreme values and they tend to influence means, but not so much modes or medians. And there's identifying pictures here. Normal distribution curve with mean, median, and mode. In the normal distribution, the mean, median, mode are at the center of the distribution. And that's with all symmetric one modal stuff. So we use that later. And if positively skewed, we get that ordering that's down here. So the whole picture is just that's all that's really intended to be shown, that ordering for where's my pen? Okay, for the positively skewed. So positively skewed, think like that. It's a sort of a picked way of the whole slide. And similarly, and I lost my pen. So for the negatively skewed, again, we have this order here. And we can go down measures of variability, just how wide they're scattered. We have these three. We've seen those interval or ratio data. We've seen those before. The range is the difference between the largest and the smallest. Real easy calculation. Usually don't have students with trouble with that. Now we talk about the deviations and population. So play around with this deviation idea. And because of the sum of the deviations are always 0, we square them up to get a useful term in the range, and that's SS, which is sigma squared for population. And we now have a definition of the standard deviation using SS terms for populations, which we have all the values. That's a matter of definition. If the population is the students in a class, that's reasonable to place in there. So go through and talk about how things differ from the samples and notation. SS is actually the same calculation as sample and population, just a little different notation. Degrees of freedom, though, this is simply a way to say we don't divide by n in a sample variation. So this is the argument there. And these are our formulas for variance and standard deviation when we have a sample. And those sample standard deviations and variances will give a larger value than the population value. And then we work through this with FX in number of pets in a home. You know, I'm trying to think about the homes I've lived in. If you have a fish tank and you have like 5 fish in it, that isn't too much with certain types of fish. But if you have you know, dogs and cats, you might only have one. So currently I only have one dog in my house, and I think she wants to go outside soon. So I should let her and finish the class, right? So here's a calculation with the frequency tables of doing the sample variance and sample standard deviation. And relationship here, here's a data set with all the same variances and with all the same, where they have all the same mean, median, mode, same central tendency, but radically different variances. So we kind of need all these measures to learn about the statistics. Little note here, original means given individual values. And we have a shortcut formula. We have the shortcut formulas for the frequency tables. Talk about box plots. I didn't really have enough to do just one box plot. These are actually a bit more common than the book will let on here. So this book has less emphasis in other box plots than I've had before. So, well, I'll let you out maybe 10 minutes early today. I'll hope to get a little bit back into the assignments and giving advice on them and catching through. I know some of you've had trouble getting books this semester, and we'll work through all that. So let's stop the share, and let's call it done for the night, and stop the recording first and then end the meeting.